Hi guys, welcome to your video for Physics Grade 12. In this lesson, we're going to be speaking about conservation of energy. What do we mean by conservation of energy? Well, conservation of energy has to do with the word conserve, and that means to keep or to preserve or to contain. So, conservation of energy would obviously mean trying to keep all the energy within a system. When we look at the law of conservation of energy, so the law that governs the conservation, it says that energy cannot be created nor can it be destroyed. So energy cannot be created or destroyed. However, energy can change from one form to another. So you can change energy from one form to another. For example, potential energy can be converted to kinetic energy or kinetic energy to potential energy. You get gravitational energy, you get various different types of energy that it can be converted to. What is the most common one that you would deal with? That's right, it's heat energy. When we move, our body causes friction. Friction causes heat. So that heat energy means that one form of energy was converted to another. If I am standing really still, that means that my body has a lot of potential energy. That is stored energy to be used in the future. But what happens when I start to move about? That potential energy gets converted to kinetic energy. That means that there is a transfer of energy from one form to another. Now we know, wizards, that there has been a great loss of energy from year to year and from decade to decade. And that's why we always hear the term save energy. What does it mean to save energy? We want to save things like electrical energy. And how can we do that? So why and how can we do that? We can do that by saying, let's look at our energy consumption and try to reduce that. We try to reduce that by reducing the use of things that use up energy. We know that we want to live in a green earth or an eco-friendly environment. By conserving energy, we are able to do that. Now in physics, you work with a lot of calculations that are involved in energy. Let's have a look at some of the calculations that can occur.
So the first thing we want to look at is the conservation of energy, but we need to look at conservative and non-conservative forces. So conservative force is a force whose work is stored as potential energy and can be later turned into kinetic energy. Remember, we said potential energy is stored energy, and then later turned to kinetic energy would be obviously your energy involving movement or motion. A non-conservative force is a force whose work cannot be recovered at kinetic energy. So the force cannot be recovered at kinetic energy and is converted into another form. It's usually converted by light, sound, and especially heat. Remember, we said that heat is a very important component in regards to work, energy, and power, because heat is one of the energies that is converted the most. Once we've learned conservative forces and non-conservative forces, we can move on and we can look at the law. Remember that we stated that the law was that energy can neither be created nor it can be destroyed. So energy cannot be created and it cannot be destroyed, but what can happen? We said that it can be converted from one form to another. Once we know the law of conservation of energy, we can then move on to an example. The example says, consider a situation where a soccer player slides to a stop on level ground. Using energy considerations, calculate this distance that a 65 kg soccer player slides, given that his initial speed was 6 meters per second and the force of friction against him is at a constant 450 newtons. what would be the first step in doing this example? Your first step would be to analyze the problem and to determine what you have been given. So friction stops the player, which converts the kinetic energy into another form, which includes thermal energy. When we look at the work energy theorem, we can say that the work done is then by friction, which is negative. It is added to the initial kinetic energy to produce it to zero. The work done by friction is negative because the force of friction is in the opposite direction to motion. So when we're looking at our diagram, remember that we always need cos theta. And because cos theta is going to be 180 degrees, remember in the opposite direction, we can say that cos theta is then equal to -1. So if cos theta is -1, it means that we are working with a non-conservative force. So we can say that the work done by the non-conservative force is equal to negative force of friction and the change in distance. There is no change in the potential energy. So what we are saying is that potential energy, which is the stored energy, will not affect this example. So knowing what we have, or after reducing the example, we can say that the next step would be to calculate the distance using the conservation of energy. How can we do that? We know that the conservation of energy, which is work for the non-conservative force, would equal to the change in energy kinetic plus the change in potential energy. Once we have that, we can expand this equation. Remember that this equation is going to be equal to change in kinetic energy would be energy final minus energy initial, and this is for kinetic, plus what is delta P? We said potential energy will not change, therefore delta P will be plus 0. Then what do we have? We're going to say work of non-conservative is equal to minus the force of friction, delta X, is equal to final kinetic energy minus initial kinetic energy. Once we've done that, when we look at the final kinetic energy, it says consider the situation where the soccer player slides to a stop. So the soccer player ends up at 0. His kinetic energy is 0 because he's not moving. There is no motion. So we can say that this kinetic energy final is equal to 0. Why is it 0? Because the soccer player, he slid all the way to the stop. Then we got minus force of friction, delta X, equal to minus the initial kinetic energy. Because I end up with minus force of friction, delta X, equal to minus initial kinetic energy, I can say that I can drop off the negative sign and say force of friction, delta X, is equal to energy kinetic of the initial player. Once I have that, let's build on the calculation. If I have force of friction, delta X, equal to energy initial kinetic, what is kinetic energy equal to? If I were to calculate it, I know that this is going to be equal to half mv squared. Initial. So what would I have? Force of friction, delta X. If I wanted delta X, I would say delta X is equal to half mv squared all over force of friction. So let's do that. Let's say 65 half 65 kgs because that was his mass. His initial volume was 6 all squared all over 450, which was your force of friction. Do you remember we calculated the force of friction? They said that it was 450. So this is going to be equal to 2,60 meters. So how can we quote the final answer? How can we state the final answer? We can say that the footballer comes to a stop after sliding 2,6 meters. And the important point of this example wizards is the amount of non-conservative work. So the non-conservative work that is equal to the change in the mechanical energy. For example, you must work harder to stop a truck, which is its large mechanical energy that contributes to this, than to stop, for example, an ant or a small bicycle. So by looking at the various different objects, we can see that mass plays a very important role. The larger the mass, the more the energy that is required to stop or even start it. So we can say that when one increases, when the mass increases, the energy required also increases. That shows a direct proportional relationship. Direct proportional relationship means if I have mass and I have energy, when one increases, the other increases. When energy increases, mass increases. When energy decreases, the mass should be smaller. So what are we saying? We are saying that it is dependent on the mass of the object. Depending on how heavy or light something is, the mass will affect the energy required to either start or stop the object.
So guys, I hope that you've learned from that example how we use the law of conservation of energy. Remember that you can use various different energy types like potential energy and kinetic energy and use the transfer from initial and final to do your calculations. Now wizards, there is an iWhiz website which is www.iWhiz.co.za. On that website, there are worksheets for you to download and go through. Those worksheets have examples on the conservation of energy as well as the law of conservation of energy. Those worksheets will help you understand this section. So go ahead and download them and try to do them on your own. So wizards, go ahead and complete those worksheets and try to do as many as you can. Good luck.
We need to learn to live with the COVID virus, the new normal, at least for the next few months. And we have just what you need to make sure you never miss a single school lesson. And it's absolutely free, mahala! High quality, powerful, animated lessons for all your subjects. So don't spend a cent until you have tried iWhiz. It's everything you need. All video lessons, textbooks, workbooks, exam prep. We want you to ace 2021. We need to learn to live with the COVID virus, the new normal, at least for the next few months. And we have just what you need to make sure you never miss a single school lesson. And it's absolutely free, mahala! High quality, powerful, animated lessons for all your subjects. So don't spend a cent until you have tried iWhiz. It's everything you need. All video lessons, textbooks, workbooks, exam prep. We want you to ace 2021.